Alright, moving on to problem 6. We're multiplying xy by 2x to the 4th y plus x squared y squared minus 3xy. And I think just simply distributing is going to work here. I'm going to wind up multiplying this into all three of the terms, and I get 2x to the 5th y squared for the first one, plus x to the 3rd y to the 3rd minus 3x squared y squared, and we're done. Alright, moving on to number 7. We're multiplying t plus 3 by 2t squared minus t plus 3. And since it's a trinomial, I like to use the tabloid form to multiply. So I'm going to just move this down here along my side, so I got a t plus 3. Using that as my header, I'm going to get 2t to the 3rd minus t squared, multiplying this times that to get this times that to get this times that to get 3t, and then plus 3 times 2t squared is going to be 6t squared minus 3t plus 9. And then I'm going to get rid of some of these terms because there are like terms. We can combine them. There is not another t cubed term, but there are some t squared terms right here. So I'll say it equals 2t to the 3rd. Combine these two to get plus 5t squared. Combine these, oh, they cancel each other out, how nice, plus 9. And we're done. Moving on to problem 8. What is it? Oh, we're going to do little Pascal's triangle here. It is x plus 5 to the 3rd. And I'm going to create a Pascal's triangle, starting with 1 at the top of my pyramid. And then we have a 1 and a 1. And 1 plus 1 is 2. And then another 1. 1 plus 2 is 3. 2 plus 1 is 3. And a 1. And is that all I need? I only need to the 3rd, right? So I'm starting at the 0, the 1st, the 2nd, and the 3rd. There, done. So here are my coefficients. I'll spread them out on my paper. I've got a 1, and a 3, and a 3, and a 1. So I'm going to take the x and make it to the 3rd power here, x to the 2nd power here, x to the 1st power here, and x to the 0 power. And then I'm going to do it backwards with my 2nd term and make it so it's 5 to the 0, 5 to the 1, 5 squared, 5 cubed. Add those together since this is addition. And I get that it equals x cubed, because 5 to the 0 is 1, so 1 times x cubed is x cubed, right? Plus 15x squared, because 5 to the 1 is 5. 5 times 3 is 15x squared. Plus 75x, because I have 5 squared, which is 25 times 3, and then x to the single power. And then this is 1 times 5 cubed, which is 125. And I'm done. And let's do problem 9, which is another Pascal's triangle problem. Hopefully you can see that. 9. It's going to be 2y plus 3 to the 4th power. And this time my Pascal's triangle will be a 1, and a 1, and a 1, and a 1, and 1 plus 1 is 2, and 1. Another 1, 1 plus 2 is 3, 2 plus 1 is 3, and a 1. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and a 1, and I think that's all we need. 0, 1, 2, 3, 4. There we go. I need a fourth power. Here are my coefficients, spreading them out. We have a 1 and a 1 over here, and a 4, and a 4, and a 6. Could probably give this one a little bit more room. I'd like to give these some real estate. Okay, so I'm going to do this fourth power with my 2y term first, and then 2y to the third, and then 2y squared, and then 2y to the first, and then 2y to the 0, and then backwards for my second term, we'll start with 3 to the 0, and then 3 to the 1, 3 squared, 3 cubed, and 3 to the fourth power. And again, this is addition, so we can just add these. And I'm getting 16y to the fourth, because we have a 1 and a 1, and a 2 to the fourth is 16, and then y to the fourth. And I'm getting a 96 y to the third, because we have a 3 times 4, which is 12 times 2 to the third. 2 to the third is 8, and so we get 96. Plus, I'm getting 216y squared, because we have 9 times 6 times 2 squared, which is 4. So we got 216y squared. Plus, I'm getting 216 again, only this time y, plus 81.